So I'm a PhD student in physics, and today I'm going to attempt a grade 7 math contest. Now, I used to do these contests myself when I was young, and I was never like the cream of the crop or the best or doing perfect on these exams or anything, but I wasn't bad either. I always did okay. So I'm curious today to see how well I'll do. These questions are inherently tricky, and you study something like physics or chemistry or whatever, and the problems look really complicated if you're young or you're in high school and you think, oh my god, what's the math going on there? It turns out a lot of it isn't really that tricky. It's more like learning another language and you get used to it. But what these tests really get at is those confusing parts. And these confusing things sort of go from when you're younger and they show up in this physics or chemistry or whatever subject you're taking later on. And it's these things that make the problems hard. And so what these tests do is they take those little things that make the problems hard and they boil it down into simpler questions that you can answer when you're younger, but that you don't need to have a lot of prerequisite knowledge in order to answer them. Anyways, please be sure to like, subscribe, drop a comment for what you want to see next. There's a Discord server as well. There's a link in the description to that if you want to come and hang out with me and other people in physics and math and look at various projects and stuff. Let's get started. So here's the front page. We have the Gauss contest from grade 7. Gauss, of course, being a famous mathematician. I'm just going to do all the notes for the questions with my pencil here on the page. This is from May 13th, 1998, and it was a Wednesday. But I already knew that because I'm really smart. I already calculated it was Wednesday. Didn't even need to tell me. So there's 1 hour for this exam. I'm going to try and do it in 1 hour. All right. So the way these work is there's 3 sections. There's part A, part B, and part C. And part A is usually the easiest. And part B gets harder. And then part C, there's less questions, but they're pretty tough. So the value of 1998 minus 998 over 1,000. And I'm already stumped because this is arithmetic. And I do everything in Python now with coding. So there's no way for me to answer this question. No, this is going to be 1. The number 4, 5, 6, 7 is tripled. The ones digit in the resulting number is, well, I know the last digit is 7. And if this number is tripled, you have 7, 14, 21. And so the 1 is the last digit. It doesn't matter what this first part of the number does because it's just 10, right? If I triple this number, it's going to end in a 0. But it's the 7 that matters here. So the last digit is a 1. S is equal to 6 times 10,000, 5 times 1,000, 4 times 10. So this is the 10,000th digit, the 1,000th digit, the tens digit. Now, see, they did a trick here because they want to trick these kids, right? You would think, oh, it's 4 times 100 because it's going 10,000, 1,000, 100. No, it's 10 and then 3 times 1. So this is 60,000, 5,000, 40, and 3. So the answer is B here. Jean writes 5 tests and achieves the marks shown. What is her average mark? Okay, so she gets 80, 70, 60, 90, and 80. So the average of these is going to be, well, I can ignore the 0 and I can just go 8 plus 7 plus 6 plus 9 plus 8, and it's all divided by 5. So it's 15, 21, 30, 38 divided by 5. And that's going to be 76. That's a 0.6. So yeah, she gets 76 average. Answer is B. I'm going to use a different color to circle so I don't lose track of this. Blue is going to be for circling. And red will be my work. Okay, if a machine produces 150 items in 1 minute, how many does it produce in 10 seconds? Well, 10 seconds is 1/6 of a minute, so it's 1/6 of 150. And now you get to see how fast my mental math is. Oh, that's 25. I had to actually look at that and try that out. In the multiplication question, the sum of the digits in the 4 boxes, I have not done this in years. 9 times 2 is 18, carry the 1. 15, carry the 1. 8 times 2 is 16, 17, so there's a 1 there. Oh, and I can get rid of this. 9 times 9 is 81. My God. 9 times 7 is 60. 9 times 7 is... Can I do this? 63 plus 1. I'm expecting a 4. What's going on here? 9 times 9 is 80. Oh, carry the 8. My bad. 63 plus 1 is 71. 1 carry the 7. 9 times 8 is 72. 9. I hope that's right. This might be the question I get wrong. 4 times 9 is 36. Okay, I gotta get rid of this. Carry the 3. I always hated all those numbers that got up there when you were doing this when you're younger. 4 times 7 is 28. 28 plus 3 is 31. Now, does this work with what's going on the rest? 8 times 4 is 8, 16, 20 over 32. Plus 3 is 35. Okay, yeah, so that's consistent. And then I add all these together. 8, 6, 7, 8, 14. 14, so I carry the 1 here. 1 plus 1 is 2. Plus 9 is 11. 12. 2, carry the 1. And does this work? 1 plus 7 is 8. Plus 5 is 13. Yeah, and it all is consistent. So 1, 1, 9, and 2. So the sum is 10, 11, 13. And circle that in blue. A rectangular field is 60 meters long and 60 meters wide. Okay. So it looks like this. 80 by 60. If the fence posts are placed at the corners and are 10 meters apart along the 4 sides of the field. So I guess there's fence posts are placed 10 meters. How many posts are needed to complete the fence? Well, this is kind of a trick. I can already tell what they're trying to do here. They're placed 10 meters apart. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 here, because if each gap is 10 meters, then there's actually going to be 9 fence posts on this side here, right? I don't have the room to draw that. But if I have a side that's 80 meters and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, then 9 posts are needed if each one of these is 10, 20, 30, 40, 50, 60, 70, 80. Similarly, 9 posts are going to be needed on the other side. So I have 18. And then in the middle, it's 60. I need how many more to complete that? 1, 2, 3, 4. So I have 1, 2, 3, 4, 5, 6. So the number of posts in the middle is 5. So 18 plus 10 is 28 posts here. Tuesday highest temperature was 4 degrees higher than that of Monday's. Okay, I'm just going to write this as an algebraic equation. T is equal to 4 plus M. W is equal to M minus 6. And T is equal to 22. Tuesday's high temperature was 22 degrees. What was Wednesday's high temperature? Well, Tuesday is equal to 4 plus M. So that means that M is equal to 18. And Wednesday is therefore 18 minus 6, which is 12. So 12 degrees Celsius. Two numbers have a sum of 32. Okay, again, I can cheat here. A plus B is equal to 32. Not really cheating, but I don't know if they teach this in grade 7. I hope they do. If one of the numbers is negative 36, so I'll say A equals negative 36. What's the other number? B minus 36 is equal to 32. So 38, 68. The other number is 68. Make sure there's no trick here. If they have the sum, one of them is negative. Okay. At the water park, Bonnie and Wendy decided to race each other down a water slide. Wendy won by 0.25 seconds. So W is equal to Bonnie minus 0.25. Bonnie is 7.8 seconds, so Wendy was 0.25 seconds faster. So she's going to be 7.8 minus 0.25, which is 7.55 seconds. Okay, that's the first part A. That was the easy part, so now we start getting to the harder part. Callan cut rectangle R from a sheet of paper. A smaller rectangle is then cut from the large rectangle R to produce figure S. In comparing R to S, we have to say which is true here. So I know that this side is 6, right? The area and perimeter both decrease. Well, the perimeter is the same because this is like having this here, and this is like having this here. So when you cut it, you have sort of this blue and this green here, whereas if you don't have it, you have it here. So perimeter is the same. And the area decreases. The area decreases and the perimeter stays the same. That is option E here. Steve plants 10 trees every 3 minutes. Good for you, Steve. If he continues planting at the same rate, how long will it take him to plant 2,500 trees? 10 trees per every 3 minutes times X minutes is equal to 2,500 trees. This is just, it's kind of like high school algebra a little bit. So X is equal to 3 mins divided by 10 trees times 2,500. And that's just, what is that? 250 divided by 3. So 250 divided by 3. 250 minutes. By the way, 250 minutes is how many hours? 60, 120, 180, 240. So 4 hours and 10 minutes. It's 250 times 3. Because 250 divided by 10 is 250 times 3 is 750 minutes. And in hours, that would be, 10 hours gets you 600. Then 2 hours to 720. So it's then 0.5 hours for the next 30 minutes. So it should be 12.5 hours. The pattern of figures, oh no, this is like an IQ question. The pattern of figures, blah, 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 is repeated in the sequence. Light triangle, dark circle, square, dark triangle, light circle. The 214th figure in the sequence is, well, it's repetition. It repeats every 5, right? And so, I'm thinking of like Python indexing here, where this is element 0, 1, 2, 3, 4. But knowing that it probably isn't that, this is probably figure 1, 2, 3, 4, 5. So everything that's a multiple of 5 is going to be a light circle. That includes 215. So 215 is going to be a light circle, which means that 214 is going to be a dark triangle. Again, this is my guess. We're going to check at the end. I think this is correct. A cube has a volume of 125 centimeters cubed. What is the area of one face of the cube? Okay, well, this is actually not too bad. But again, it's kind of tough if you're in grade 7. So each wall has a length of 5 centimeters because 5 cubed gets you 125, right? 5 times 5 times 5 is 125 centimeters cubed. The area of one face would be 5 times 5 or 25 centimeters squared. The diagram shows a magic square in which the sums of any this is Sudoku or something like that. The sums of the numbers of any row, column, or diagonal are equal. What is the value of n? Well, I don't know if this counts as a diagonal. I'm going to assume not. But 8 plus 9 plus 4, 17. So the sum is obviously going to be 17 plus 4 is 21. 21. And then we have 9 plus something plus 5 is equal to 21. Well, 9 plus 5 is 14, so this is equal to 7, right? And then I can fill in this one here. 8 plus 7 is 15, so this must be a 6. 6 plus 5 is 11, so this must be 10. And then this must be a 3. And then 3 plus 7 is 10, so n must be 11. Each of the digits 3, 5, 6, 7, and 8 is placed 1 to a box in the diagram. If the 2-digit number is subtracted from the 3-digit number, what is the smallest difference? The smallest difference. So it wants the numbers to be as close together as possible. I guess my strategy here is I might go like 3 for this. And what's the smallest difference? I put 3 here, and I would put I think I would put 8 here, because if I put any other numbers like this, it's just going to be too big. And I'm going to want this number to be as small as possible, this middle box here. So I'm going to put a 5 here. And then I have two more numbers. I have 7 and 6. And if I put a 6 here and I subtract this 7, it will be smaller, something like that. And so the difference here is, well, this is, I don't even remember how to subtract numbers. 356 minus 7 is 349. I'm doing this a really basic way. And then 349 minus 80 is 269. I'm going to guess the answer here is 269, but they give this option of 261 as well, which has me concerned. But I don't think you can get that. So I think we're all good here. What happens if I put a 7 up here? If I put 7, 6, then I get 1. It ends in a 1. I have to borrow, that's what I do. 15 minus 8 is 7. And I forget what I do with this other number. 271. No, so there's no 261. No, I'm pretty sure 269 is the answer. Claire takes a piece of paper and folds it in half 4 times without unfolding, making an isosceles right triangle each time. After unfolding the paper to fold a square again, the creases on the paper would look like, oh, this is just awful. So if I take a piece of paper, isosceles is 2 sides are equal. So I think I know what they mean here. I'm going to draw it like this. The first time you fold it, the crease is going to be like this. Second time you fold it, well, then my triangle looks like, I have something that looks like this. I have to fold it to make an isosceles triangle so that 2 sides are equal. I think I fold it like this, because then this and this are equal, right? For definition, this is the center of the square. So that's 2 folds, and I have a triangle that looks like this. 1, 2. Then she folds it in half another time to make another isosceles triangle. So how would you fold a piece of paper like that in half? Well, if I fold it in half here, are 2 of the sides equal? Yes, because now, and I'll draw this in purple, this side and this side are equal. So 1 is the red fold. 2, 1, 2, 3. Okay, so is this looking like any of these so far? I definitely have like something that looks like this, but I don't think this is the answer because there's one more fold that needs to happen. I think the final crease looks like this, because then this side and this side are equal. So I think the answer is C. This is a weird question, not the kind of math I'm used to, but we'll see if this is correct. Oh, we're getting to part C pretty soon. The letters of the word Gauss. Okay, why don't you just mention yourself on your own exam? No. And the digits in the number 1998 are each cycled separately and then numbered as shown. If the pattern continues this way, what number will appear in front of Gauss 1998? They're cycled, okay. So I'm going to put 1, 2, 3, 4, 5, and 1, 2, 3, 4. So here the cycle is 2, 3, 4, 5, 1. This looks a little bit to me like the Kronecker delta function, in that there's a cyclical property of that. Then you have 3, 4, 5, 1, 2, 4, 5, 1, 2, 3. And this is 2, 3, 4, 1. And this is 3, 4, 1, 2. And this is 4, 1, 2, 3. And if this pattern continues this way, which number will appear in front of Gauss 1998? So this number here, I assume they're talking about. And so I need to do it. It needs to. They both need to cycle so that it lines up. So this is tricky, eh? So 2 more times, and I'll have 1, 2, 3, 4, 5. But 2 more permutations of this gets 2, 2, 3, 4, 1. So this will be 5, right? Because 2 more, and then I'm back to 1, 2, 3, 4, 5, 2, 3, 4, 1. But then I need to cycle it again. So at 10, because it'll be 1, 5, and 10. So that's 2 goes in front for 6, 3 goes in front for 7, 4 goes in front for 8, 5 goes in front for 9. So then I have 1, 2, 3, 4, 5. And here I have 3 goes in front for 6, 4 goes in front. I'll do this with this pointer. So 2 goes in front for 6. Sorry, 3 goes in front for 6, 4 goes in front for 7, 1 for 8, 2 for 9, and 3 for 10. So 3, 4, 1, 2. And so I assume it will do, so 15, right? Continuing this pattern at 15, 4 will be in front, and at 20, 1 will be in front. Again, and we'll get back to that original pattern. So the answer here is 20. That's a little bit complicated. That's like 2 things have to cycle to eventually line up the same way each time. Juan and Mary play a 2-person game in which the winner gains 2 points and the loser loses 1 point. Oh, this is really annoying. If Juan won okay, I'm gonna have to write this as an algebraic equation here because this is annoying. If Juan won, that's annoying. Juan won exactly 3 games, and Mary had a final score of 5 points. How many games did they play? All right. Let's think about this for a sec. How can I write this as a simple equation? So the winner gains 2 points. The loser loses a point. So I have P1 plus P2. No, that's not a nice way of writing it. 3W plus, W is equal to 2, and loss is equal to, L is equal to -1. So 3W plus, and how many games do they play? They play, Mary had a final score of 3 points. So, 1 won exactly 3 games. So here's 1. And I have 3W. And Mary is, we don't know how many games she won, so X times W plus Y times L. I'm starting to get stumped. I'm not on part C yet. I think I'm trying to do this algebraically where I don't need to do it like this. This is not so simple. 1 won 3 games. Mary had 5 points. So Mary gained 2, maybe. She had, I'll go like this. So W, I'm just going to say win W, M, WJ, L, loss of Juan, and loss of Mary. And so Juan won 3 games. We don't know how many points Juan got. And Mary had a final score of 5 points. So how many games did they play? So final score of 5 points. Well, suppose they played 4 games. If they played 4 games, then Mary would have only won 1 game. Let's just go through each of the options, right? I think that's the simplest to do here. If they played 7 games, right, then that means that Juan won 3 and lost 4. So we'd have 3 times 2 minus 4 times 1. So he'd have 2 points. But he would have 2 points. And Mary, well, how many games did Mary win? Mary would have won 4 games, 4 times 2, minus 3 times 1. So that's 8 minus 3 is 5 points. So in this case where Juan wins 3 games, so Juan is 3, Mary is 4. Then Juan gets 3 times 2, and it's 7 games total, right? That's a total number of games. Then Juan has 3 times 2 points minus 4 times 1, which is 2 total. And Mary has 4 times 2 minus, she won 4 games and she lost 3 times 1. And that's 8 minus 3 equals 5. So I think it has to be 7 games. I just got lucky choosing the first option. Yeah, weird question. There's probably an easy way of doing that, but whatever. Each of the 12 edges of a cube. 12 edges of a cube. Oh, like the actual edges is colored either red or green. Every face of the cube has at least one red edge. What is the smallest number of red edges? That's another one of these just awful questions. It's just annoying to solve. So if I draw a red edge here, right? Every face has at least one red edge. Well, I feel like I could just go like, if I just stack them like this, then what faces all 4 up at the bottom also needs a red edge, and the top also needs a red edge. So if I distribute those as far away as possible, then all 4 of these are covered, right? But I still need to cover the top and bottom, which means I can put a red here and a red here, like that. And then the answer was 4. The question is, can you cover all the faces with just 3? And I don't know if you can, right? But this seems to be wasting. Can you cover the top and bottom each with an edge? I think the answer here is 4. I could be wrong. This might be the question that I get wrong. Part C. So now we're at the tough part. I found part B kind of tough. So we'll see about part C. 10 points are equally spaced around a circle. How many different chords can be formed by joining any 2 of these points? A chord is a straight line joining 2 points on the circumference of a circle. How many chords can be joined by joining any of these 2 points? So you have 10 points, right? And so I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 lines to connect those. And then I can have that for each of the 10 points. minus the repetitions, because of course some of them are going to be the same, right? If I go here, then here to here is also the same as that. This is kind of like those sums where you this sort of thinking comes up in advanced physics problems as well. But for example, if I'm going 1 2 3 4 5 6 7 8 9 10, then this one also goes 1 to 10 minus the point that it already is. And if I count all of them, then I get 90 divided by 2, you know, because some of them are going to be repetitions. For example, if I'm starting here and I go to all those, so like 1 2 3 4 5 6 7, you note that I repeat this one from this one as well. So this is going to be 45. Each time a bar of soap is used, its volume decreases by 10%. What is the minimum times a new bar would have to be used so that less than 1/2 of its volume remains? This is a classic question that shows up in things like exponential decay, right? And that's what this is. This is an exponential decay. So I would say each time it's used, its volume decreases by 10%. So it goes, suppose its initial mass is 1, then it goes to 0.9, right? Then it goes to 0.81, because 10% of 0.9 is 0.81. And then is there an easy way of doing this? With a calculator, there is a formula you could set up for this. So it's V is equal to 0.9. This is the V after the nth try, so the volume after n is equal to 0.9 V to the power of n, right? And so each time I do it, it's 0.9 V. Then it's, well, I'm going to actually go like this. There's no V to the power of n. It's 0.9 to the n times V. So it's 0.9 V. So V is equal to 1. It's 0.9. Then it's 0.9 times 0.9, which is 0.81, etc., etc. And without loss of generality, I'll set V equal to 1. And I want 1/2 is equal to 0.9 to the n. And so n, if I take the natural logarithm, which I wasn't expecting to do in this exam, it's a ln of 0.5 divided by a ln of 0.9. But of course, I can't really do this because I'm not going to use a calculator here. So what I can just do is, first time I do it, I go to 0.9. Second time I do it, 0.81. Then 0.81 minus 18. That's 0.73, 0.63. Right? 10%. Am I doing that correctly? Why did it drop so suddenly? 0.9. 1. Here dropped 0.09. 10% of that is 0.081. This is an annoying thing to write out. Are we allowed a calculator on this test? Each question. Calculators are permitted. Well, you could just take a calculator, I suppose, and multiply it times 0.9. Do I have a calculator around? Yes, I do. Very lucky. So the first time it's, and it's apparently out of battery. That's great. Oh, it's turned on. I squeezed it hard enough. So the first time is 1 times 0.9 times 0.9 times 0.9. So this would be using it 1, 2, 3 times, 4 times, 5 times, 6 times, 7 times. I think the answer is 7. All I do is I keep multiplying by 0.9 until I get the answer. So if I go 0.9 to the power of 7, then I get less than 0.5. That's what I want. A cube measures 10 centimeters by 10 centimeters by 10 centimeters. Okay. So I assume each side is 10 centimeters like this. 3 cuts are made parallel to the faces of the cube, as shown, creating 8 separate solids. Okay. What is the increase in the total surface area? That's a tricky question here. And the truth is that the increase of the total surface area, so the original surface area is 10 by 10, so 100 centimeters squared times 6, so that's 600 centimeters squared, right? And now I have 8 cubes, each with a, which are then separated. So 8 cubes, each with 5 centimeters by 5 centimeters. So I have each, like this area here is 25 centimeters squared. So 25 centimeters squared times 6 times 8, because I have 8 cubes. And this is 25 centimeters squared times 40. I'm going to use my calculator again because I don't want to do this. I realize you can do this. 25 times 48. And I have 1200. And so the increase in surface area is 600 centimeters squared. Of course, they put 1200 to try and trick people. On a large piece of paper, Dana creates a rectangular spiral by drawing the line segments of lengths in centimeters 1, 1, 2, 2, 3, 3, 4, 4. Dana's pen runs out of ink after the total of all the lengths he has drawn is 3,000 centimeters squared. 3,000 centimeters. What is the length of the longest line segment that Dana draws? Now, I know an easy way to solve this because this shows up in like the sum of numbers. And you know that 1 is repeated twice, 2 is repeated twice. So really what this is the sum of the first n numbers times 2. So I have 2 times sum of I equals 1 to n of I, right? And he's drawn 3,000 centimeters, so this is equal to 3,000. But the sum of the first n numbers has a formula, and that's equal to 2 times n plus 1 divided by 2 is equal to 3,000, right? And the 2's cancel out, right? Because this is the sum of 1 plus 1. This sum here is 1 plus 2 plus 3 plus 4 plus 5. And this here is a formula that you learn in university or something. It's the sum of the first n numbers. And so these cancel out, and I have n times n plus 1 is equal to 3,000, right? This is actually a quadratic equation, which is tough for grade 7 that they're asking this. But it's basically the product of 2 consecutive numbers is equal to 3,000. Now, I want to get it to at least 3,000. So suppose I have n, I'll just do some trial numbers here, right? If I go like 15 times 15 plus 1, right? Suppose that's 15 times 16. No, that's way too small. 100. What about 50 times 50? Yeah, so it's more in that order of magnitude. So it'd probably be like maybe 55 times 56. No, it's less than that because that's 3,060. Maybe 54 times 55. Okay, so that's 2970. And this is n is equal to 54. And n equals 55. I have 55 times 56. And this is equal to 3060, I think. So somewhere in the middle, you get there. So after he's drawn 54, so he'll have 54, 54, like this. And then he goes, he's at 2970. And then it runs out at 3,000 centimeters. So he gets like 30 long here. And then his pen runs out. So the longest that he's drawn would be 54. So that's a tough question. And then, of course, some annoying little thing at the end. 2 natural numbers, p and q, do not end in 0. This is math stuff. This isn't fun stuff. This isn't physics and solving for electric fields. This is math, natural number stuff. They do not end in 0. The product of any pair, p and q, is a power of 10. That is 10, 100, 1,000, 10,000. If p is greater than q, the last digit of p minus q cannot be. Well, this is a fun little thing here. So the product of any pair, p and q, is a power of 10. So what gives you powers of 10? Well, 5 times 2 gives you a power of 10, right? If it's 100, that could be, they do not end in 0. So I was thinking like 10 times 10, but those end in a 0. Does 100 have any other... I'm thinking of the prime factorization of 100 here. 10, 10, 5. It could be like 25 times 4. Right? And so let's cross off some options. So we know 5 times 2 is a viable option for P and Q. And so the number we consider here is 5 minus 2 equals 3. So 3 can be an option. So I'm going to cross this off. 25 minus 4. So that's 25 minus 4 for P and Q. For example, I'm just going here. This is P. This is Q. This is P. This is Q. It gives 100. 25 minus 4 is equal to 21. So 1, it can be 1. Let's try another thing. So is there any other options here? Because 100 is broken down into the factorization 5, 5, 2, 2. Right? So 4 times 25 or 10 times 10 is the only option there. 1,000. Well, that's 10 times 100. Or this is 5, 2. And 1,000 is just 100. So I'm just going to write it as, we have 10, 10 times 10. So these are the factorization here. And numbers that I can have here would be like 25 times, what is that? 40, but then one of the numbers ends in a 0, so that's not okay. I could also have 125 times 8, right? And that will give me 1,000. Now, the issue here is that 125 minus 8 is 117. So 7 is not going to be the answer here. So it's either 5 or 9. So we'll try 10,000. Or maybe we'll try another combination of 1,000. I could also have 5 times 2 times 2 is 20. No, we can't have that. 2 times 2 is 4. 4 times 2, 50. No, we can't have that. Well, 10,000, we have another factor of 10 here. We have another factor of 5 and 2. So I could go 25 times, well, something that's going to end in 0. I think we have to go to the middle numbers here. So I could try like, what's 5 times 5 times 5 times 5? 625. So those are all my 5s, and all my 2s are 2 times 2 times 2 times 2, which is 16, right? And does that give me 10,000? 625 times 16. Yes, and if I subtract these, the last digit of P minus Q is at 619, 609. The last digit is a 9, so I guess therefore by default the answer is gonna be 5. All right, well, I guess it's time to check over the answers. All right, so I'm checking over the answers. So the first question answer was indeed A. So check. I'm nervous. Question 2 is E. Yes. Question 3 was B. Yes. 4 was B. Yes. We're good. 5 was D. Yes. 6 was A. 7 was C. Excellent. 8 was C. 9 was A. And 10 was C. Excellent. 11. First answer was E. 12. The answer was E. 13. The answer was D. 14. The answer was B. 15. The answer was E. Very nice. 16. The answer was A. 17. Oh, this was the tough one. The answer was C. Oh, good. Very good. 18. The answer was E. Nice. 19. The answer was A. Good. And 20. The answer was... Oh, did I get that wrong? The answer was B. Oh my. I messed this up. So I had these 4 edges like this. But if you draw the cube like this, and I put one here, and one here, then all the edges are covered. So you could do it with 3. So I was wrong here. Well, apparently I'm not a mathematical genius for grade 7, but that's all good, because somehow I'm doing physics. 21, the answer was B. 22, the answer was C. 23, the answer was D. 24, the answer was... It was a long answer. Answer was C, yes. And 25, the answer was C. So I got everything correct except for this part B question, which the answer was 3. Should have been 3, and I put 4. So there you have it. This is a PhD physics student doing a grade 7 math contest. Did I do perfectly? I didn't. I got tricked here on this question 20 for part B. Anyways, I'll be doing more of these tests in the future, and I hope you enjoyed. And please be sure to like and subscribe as well.